This video is just to go through how to do certain graphs on the calculator. There's another video I've put on the Hive for graphing in general, so graphing sort of regular type situations, but this one's for graphing non-regular, irregular type situations. So normally when we graph we get this function here which is f1x equals, and that f1x is in place of y, so it's like saying y equals, so for instance y equals 4x plus 8, we would graph like that. And then we can manipulate the window, we can find x and y intercepts, we can find other points, we can do certain things with it. That's in another video. What I want to talk about is how to graph things like 2x plus 7y equals 9. If we put that there and press enter, nothing's going to come up because that isn't in the format that the calculator needs it to be. This needs to be y equals and then mx plus c, or some variation of that, but it's y equals. If we press delete or backspace to delete the equal sign, it comes up with other options. So these other options here are inequalities. Equals is obviously the one we always have there anyway. So if it was y is less than or equal to 4x plus 2, we could use that one. But I want to talk about the relation. If we click on that, it says relation 1 of x and y, and it leaves a blank space here. So in that blank space, we can actually put any relation linking x and y. So we could put y equals, say, 5x take 4. That's in the format that we could use the other one with. Or we could use this sort of form and press enter. So that's going to graph that relation, not just when we have it in the form y equals mx plus c. The other benefit of this, and if I press tab I get back up to that, is I can put inequalities in here similar to those we'd see in an objective function type situation. For instance, we might have 3x plus 8y is less than or equal to 48. And we can adjust the window, do a bit of window adjustment just so we can see a bit more of it. I can get rid of that. So this shows a little bit more of the graph. The benefit of that is if I press tab and go up, I can see my graph that I can then edit. If I press down again, I can enter another one. So let's say we had another one that was x is greater than or equal to 0. That's going to graph that as well. And then tab will be able to do another one, so this time maybe y is greater than or equal to 0. And so at the moment, just getting rid of those equations, because the calculator will always shade what I want, what the inequation wants as the feasible region. So if you're doing more than one on the calculator, the area that we want in total, the combined feasible region, will be shaded in all of the different colors. So this area here is pink, it's purple or blue, and it's orange. So it's kind of that dark sort of muck color there. Now, that's a little bit hard to follow, especially when we've got, let's say, another relation. We could have, I just want to see what is the other one I've put in there. So let's say we've got 5x plus 2y is less than or equal to, let's say, 15. So it just adds more complexity. It's this area in here that's the feasible region, and that's not obvious here. If we put it in the calculator shades what we want, so therefore the combination of all the colors is the feasible region. That's this one in here. Now that's because I know what's going on, that I can spot that. But if I had no idea how to find the feasible region and I graphed all of those, I wouldn't know which section here was what I actually wanted. So a little trick you can do is when you're graphing them on the calculator, you can swap the direction of the signs. So this is what the equation is, but if I change that to greater than or equal to, that'll shade the opposite. Now this will become obvious what's going to happen as I go through and change all of the signs. So I'm just pressing tab and up to go to the inequalities. I'm changing the direction of all the signs, and you can hopefully start to see what's happening. If I change the last sign direction, what you can see is that the calculator is now shading what I didn't want because I've changed the direction of the sign of the inequations. So instead of having less than or equal to there, I've got greater than. So the calculator is shading greater than, leaving less than blank. And that's similar to how we do this by hand. If we shade what we don't want, then the feasible region is the bit that's left blank, and that's more obvious now. So I can graph all of those. Now that's 4 different relations, 4 different inequalities or constraints, and the calculator is showing what the feasible region as the blank space. And that's easier to monitor than when the signs were the right direction and it shaded what it did want. It was just a big mess. So it's a lot easier to switch the direction of the sign to allow the calculator to shade what you don't want, which is similar to how we do it by hand. Now don't forget, in the exam or in a SAC, if you're shading what you don't want, you need to highlight the feasible region. So I'm suggesting you take a highlighter into the SAC and into the exam. Use your pen or pencil to shade the areas or the sides of the lines you don't want. And then once you've worked out your feasible region by what's left over, highlight that. And I would even write RR, required region, or FR, feasible region, in that space. A lot of the examiner's reports from the past year's exams say that shading what you don't want is absolutely fine, but if you don't emphasize that this is the feasible region, then you will not get a mark. So it's okay to shade what you don't want, but you have to indicate either with a legend or a key or an arrow or a highlighter or the letters FR or RR, required region or feasible region, then you won't get marks for that. So be careful with that. So I'm just going to open a new page just to show you again. If we go to graphs, if I press delete to get rid of the equals, I can then choose option 6, which is a relation. And then I can input a relation there, any sort of relation linking X and Y.